Hello, hello, hello. I've been told that I need to get going, and my time has started already. So yeah, yeah, I should probably start on my presentation, shouldn't I? Here we go. Yeah, so my name's Dan Jones. I'm the Wi-Fi guy. I work for a company called Hamina, call us whatever you want. We make like a software as a service Wi-Fi design tool, right, so that you can build this stuff. And what I want to talk to you about today is how Wi-Fi actually works. And I wanted to give you something that's like, because I'm aware that not all of you are in charge of the networks that you're kind of having to put your devices on, right? So what I wanted to give you was some like, if you do these things, your Wi-Fi will be okay. So this is me. The QR code is my LinkedIn. Like, I am here to serve the communities that I talk to, right? So please, please, please feel free to message me on LinkedIn, or my email address is there. Send me an email. I am super happy to help. I'm in the Wi-Fi channel on Mac Admin Slack. I try my best to kind of get in there and help when I can. So. Wi-Fi. So it feels to me like there's like these two different types of people, right? There's these people that say, you know, Wi-Fi's easy. You just add more APs in, that'll fix the problem, right? And then there's these other side of people where they're like, Wi-Fi is this magical thing that no one can understand, and you know, you're on your own type of stuff. It's not magic. It's physics. There are some rules, right? Because it's physics, there are rules. And so what I'm going to kind of show you, the kind of 14, 15 things that I'm going to show you, like if you do these things, you will have good Wi-Fi. There will always be edge cases. More likely than not, if you've done all these things, the problem isn't the Wi-Fi, right? It will be something else, and I can't help you there. You need to go and talk to someone else. But in terms of Wi-Fi problems, these things are going to fix it for you. So, design is the number one. I would say that I work for a design tools vendor, right? Of course, design is the number one problem. All the things I'm going to talk to you about are going to be config things you can do, right? Config things you can change to make your Wi-Fi as good as you can with the physical locations you've got. Config can't fix stupid. Right? And as much as I would love to be able to do that with config, I can't, right? Design is the number one thing. When we look at things like how devices roam, right? That is a physical, real-world layer thing that's happening. I can't help you with config if your AP is in the wrong place. So you have to get that right. And I'll go through that. I'll go through that stuff, right? Main things that you have is you have too few APs because people just put 2 in. Like this space here, right? You could have 1 AP, turn it up to 11, everyone would have full bars of signal, no one would be able to work, right? So, for instance, let me show you. This is the current network on 2.4 in this space. If it's red, it doesn't work. This is the 5 gigahertz. Which is okay, but that's because you're all intently listening to me, thank you very much. You can see the red numbers down here. This means if they actually start doing things, the Wi-Fi in here won't work, right? So design is like the number one thing, wrong locations, things like wrong PoE. I've been to so many places where you know, they've done a rip and replace. We've taken out the old APs, we've put in these brand new Wi-Fi 7 APs, isn't it amazing? And you go and look at them, and look, the LED's on, and you're like, okay, yeah, nice. They're not sending out any radio waves because they've put a nice Wi-Fi 7 AP in, but they haven't upgraded their switch. So they haven't got enough PoE budget. So the lights are on, but no one's home. Yeah, so things like that, right? And cable lengths being too long and all that kind of stuff. So design is the number one thing, and there are a couple of ways of doing design, right? No design, which is horrendous. And by no design, what I mean is listening to the architects. Right? So the architects will make you a building plan, and they'll tell you where to put your APs. Really helpful of them. They are always in, like genuinely, if I was going to put an AP in the worst place I could possibly think of, that's where an architect puts it. It's uncanny. It is uncanny, their ability to put it in the worst place. And of course, that's what people build to, right? So they go and they put a cable to where the architects told them to do it. Yeah. Next one is the finger gun. There. Yeah, I see that all the time. And again, it's done off some sort of innate ability of them to be able to sense the Wi-Fi, right? Yeah, there. Yeah, let's put one there. It is a terrible way to design. And again, it's because a lot of the time, your networking infrastructure people, they are routing and switching people, right? And they've got Wi-Fi at home, so they must be an expert. Yeah, unfortunately, not how it works. This actually, back when I first started doing Wi-Fi, this was how I used to design Wi-Fi. Get a silo cup, you know, the American beer pong plastic cups, yeah? Get a floor plan, put one man, draw a ring around it, there you go, put an AP in the middle. That'll do us the job. That is better than finger guns, okay? That is better than finger guns. Some vendors give you they have like a design studio, right? So thinking things like Ubiquiti, Aruba, Extreme, they have these things. They're built by vendors, right? They are built to get you to buy more APs, right? I'm sure they're fine. They're better than finger guns. They're better than silo cups. But if you want to do it properly, get a proper tool. There are many tools. Hermine is the best. Right. So we're on to the kind of thing. So the first one's design. Now we get into the kind of config things. What config things can you do? Can you hand to your infrastructure people? So don't use 2.4. And I want to show you why. This is 2.4 right here, right now, as my Mac is hearing it, right, in this space. You can see there are 3 clients attached to 2.4 on this network. There's 2 on channel 1. Oh, there's 4 now. And then 2 on channel 6, right? How good of a time do you think they're going to be having on those networks? Bearing in mind they're red. It's going to be terrible, right? So amber basically means it will work eventually, right? Red means it won't work. And then green is like, yeah, okay, it's probably okay. So there are 4 clients that my Mac can hear, and it's red all the time. So that should tell you what you need to know about 2.4. Apple, I've put Apple is wrong here, and I can see these guys are getting like edgy. So Apple tells you in their documentation, the best thing to do is to have one SSID that is on 2.4, 5, and 6. I know why they say that, because all of us that are still rocking a Series 5 Apple Watch, that only does 2.4, right? It's the only device that does. But if you want your Apple Watch to work, if it's Series 6 or later, you're fine on 5 gigahertz. But if it's before that, it needs 2.4. Apple is wrong. Do not use 2.4 on your SSIDs. Oh, one thing to say, right? I know I'm talking. I know I've got the mic and stuff. If you have a question, just like wave at me. I would rather this be like an interactive. If you like, what are you talking about? Or how does that work? Like, ask. So you should use dual band 5 and 6, right? If you've got something like room booking system or, I don't know, paper tablet things, whatever they're called, remarkables that need 2.4, have a separate SSID that's just for the 2.4 devices. Do not let your laptops, tablets, mobile phones connect to a network that has 2.4 enabled on the SSID. Rule number 2. Rule number 3, don't mix your AP models. So, again, right, I don't work for an AP vendor anymore, like work selling AP stuff anymore, so I can kind of be a bit more honest, right? Marketing teams for vendors, they'll say things like, oh, this is our high density model. Oh, okay, this is our lower density model. And so what people kind of do is they go, oh, okay, well, the conference room where we have the board meetings, we're going to put a high-density model in there because we want to make sure the Wi-Fi is really good in that room. But then all the other spaces, we're going to put the cheapest one we can get, right? That doesn't work because your clients are the ones that make the decision. My iPhone is the one that says, oh, I'm going to connect to this AP or that AP or whatever. It doesn't work like cellular. So if you have this mix of models, right, what ends up happening is you'll walk past the boardroom and your phone will go, oh, what an amazing AP. And it will connect to that AP and it'll be having a lovely time. And you'll walk past 12 other APs as you go and sit down at your desk, and you'll still be connected to that one AP right at the far end. Because your phone is like, this is a great AP. It's got 8 spatial streams. It's 6 gigahertz capable. It's amazing. I'm going to love this thing. That is why you shouldn't do it. And then what happens is someone goes into the boardroom to use the boardroom, and everyone's phone is connected to that one AP, and they have a terrible time, right? Do not mix your AP models. I see this all the time. Just don't do it. Apart from if you know what you're doing, and then you can. Like I said, it's high level, right? There are some exceptions to these rules. And like, this is, like, again, I want to be a resource to this community, right? So if you're going back to your infrastructure people and they're like, that doesn't make sense, get them to email me. Get them to set up a call with me. I will happily talk to your infrastructure teams. Don't mix channel widths. Again, see this all the time, right? Oh, we've got people that are doing video editing, so they need faster access to things, so we've given them a wider channel. Don't do that. Or, hey, yeah, we got all these things out of the box, and we just left it on auto, and some of them are on 20, some of them are on 40, some of them are on 80. Don't do that, right? Again, clients make the decision. If they see an AP where they're going to get 4 times the bandwidth, of course they're going to stick to that AP where they get 4 times the bandwidth, right? They're not stupid things. The Apple devices are especially clever with how they decide which AP they're going to use. Yeah, do not use these things. My kind of like catch-all is, if you want to be safe, make everything 20 megahertz wide. Your peak speed will be lower per person, but your aggregate speed across the network will be much higher, much more stable connections. People will be able to kind of get on and off much easier, get everything they need. Cool. Next one, don't rate limit. This hotel rate limits. So, and again, this comes from just a complete misunderstanding of how Wi-Fi works. Wi-Fi works like a walkie-talkie, right? If I'm talking to you like I am now, and I'm using up all the airtime here, right? No one else is talking, it's just me. I've got all this information I need to send out, right? I'm going to talk and I'm going to get that across. If I get rate limited, all that happens is, rather than me being able to have a big long sentence like this, I have to start talking like this. And it means that I take much longer to get my point across, right? I still have the same amount of information I need to get out. It's just going to take me much longer. And I'm still talking, so you can't talk. One of the kind of analogies that I use, right, is because you're on a channel, right, you have one lane that you can use. So if you rate limit your guest SSID, your guest SSID is using the same channel that your corporate SSID is using, right? So if I'm driving along at 40 miles an hour in my corporate lane, and a guest cuts in front of me, and I've said to them, you can only drive at 5 miles an hour, guess who's driving 5 miles an hour now? Right? That's how Wi-Fi works. It doesn't work like a cable. If I say to someone, you can only drive 5 miles an hour, everything behind that is now driving 5 miles an hour. That's how Wi-Fi works. So if you've got terrible, terrible corporate Wi-Fi and it's really slow all the time, but you've got good signal and all this other stuff, probably because you're rate limiting and someone else is taking really long to talk. Okay, so yeah, I really like this meme. It's basically exactly what people are doing. So the better thing to do, right, is to use something like quality of service. So what you're saying is, these are our applications that we're using, and we're gonna say these get priority on the channel. And then all the other stuff, and even an SSID completely, they get lower priority. And I've talked about QoS before. I'm not going to go into it today. Next one, set your minimum basic rate. So again, this is relatively similar, right? So the way Wi-Fi works is there's no like collision domain stuff happening, right? It's I start talking, you start talking, oh, sorry, and then we both retry. Yeah, and so because of that, Wi-Fi has a lot of like management and control overhead in it, and that's why when you see things like your data rate is 1.2 gig, and you can only actually send anything at 600 meg, that's why. It's because of all this control and management traffic that has to happen to make that data move. And so what we're doing here is, to take it back to that kind of car analogy, what we're saying is your minimum speed must be this, right? And by default, that would be 6 megabits per second, for instance, on a 5 gigahertz network. So the safe one to change that to would be 12, yeah? So everything can do 12. I personally just say to everyone, go straight to 24, right? Just use that. The problem is there's lots of options when you go into that thing, and so you'll end up with someone who, again, doesn't really know what they're doing, and they'll go 18 megabits per second. We'll use that one. There are lots of technical reasons why 18 megabits per second is a terrible, terrible, terrible idea. Basically, if you use 6, 12, or 24, you can lose half the data and it still works. Use anything else and you're going to have a terrible time. So again, I would raise the minimum speed to something like 24 megabits per second. All of that management traffic now is 4 times faster. So it makes everything happen much quicker. Okay, use strong security. This isn't really like a config thing. This is more of a just don't be stupid thing. So many places I go to, they have like a password on a reception desk or something else, right? It's so easy for me to see all of your data if you use those things. Like just as a plea, as a security plea to you. The best thing you can do is 802.1x, right, which is certificate-based Wi-Fi connection. That's the best thing. There is some overhead with that, right? I personally prefer for everyone to use what I call coffee shop Wi-Fi, which would be OWE. So that is, OWE it's an open network, there's no password, but every individual connection is encrypted, right? It's a new thing. Macs are capable of doing it. iPhones are capable of doing it. You could turn this on today and it would work perfectly. The beauty of that is it takes away this illusion that your network is secure from the keys that you're using, and it places the kind of security risk somewhere else, how you're tunneling traffic, things like that. Much, much better way of doing it. Captive portals are the scourge of the earth. They need to burn in hell forever, and the people that make them need to suffer for an eternity. I don't know that I can be stronger than that. They are the worst things. The only people that like captive portals are the people that sell captive portals. They give you no security. They basically give you nothing useful at all. Just get rid of them. People say to me, oh, we've got a legal requirement to make sure people accept our acceptable usage policy. No, you don't. No, you don't. There is no such law that requires that. It's just absolutely. You go to an Apple store. Do they have an acceptable usage policy before you use their internet? No. You do not need it. If you, for some reason, feel like you have to have one, get them, as they sign in at reception, get them, just have something there. That's fine. Or have a poster up or something. Captive portals are the worst. And all they do is give you another reason for the internet not to work. Hiding your SSIDs. You can tell by the fact I've used the same meme, I have a same level of disdain for this particular practice. It does nothing. As soon as something connects to your hidden SSID, it's no longer hidden. It's literally in plain text in the beacon and the probe response, and it's there for you to see. If I was a malicious person and I was looking for targets, which SSIDs do you think I'm going to target first? The hidden ones, right? Yeah, but we don't want people to see the network. Call it lemons, call it zebra, call it wallpaper fluff, whatever. Put it so it's at the bottom of the list of things. Don't hide it. It's the worst thing you can do. It's actually really bad for your clients because the clients they don't get they have to know the network they're connected to. They can't just hear it on the air. So it actually makes it more difficult for your clients to connect, your clients to roam, things like that, especially on what's called a DFS channel, basically the biggest chunk of the 5 gigahertz we have. The clients aren't allowed to talk on that channel until they've heard something happen, right? Do not hide your SSIDs. And I know for a fact almost every single one of you in your network has got hidden SSIDs. It's the worst. It's second worst after captive portals. Have fewer SSIDs. Again, this I think comes from like a misunderstanding of how SSIDs work. People think they're separate networks. They're not. People think that it segregates your traffic, and they don't, right? That's all done further up. So for me, again, a single OWE network that's open, encrypted, is a much better way of doing it. And then after that, use something, Zscaler, whatever it is you're going to use, to tunnel that traffic back to where you need to be. And the reason why that's better to do is because if I'm sat at home or a friend's house or a hotel or a coffee shop, I need all those protections anyway, right? In this new kind of world that we live in where you can access all this stuff wherever you are, why would we then have a network that's different from that in our office? Makes no sense to me. Just have coffee shop Wi-Fi in your office and use all those same protections that you have everywhere else. And it will make it much faster, right? Every time you add a new SSID on, it slows down that network. And again, this is high-level, stuff. I can explain why. And the thing that I love is I go to businesses and they've got like guest and BYOD as the ones you can see, and then they've got 28 hidden networks. Turn on your amendments. So again, like I've said, it's the clients that make these decisions, right? The amendments that we have here, these are the things that help those clients make a good decision. So you've got 802.11k, and I've tried to kind of give you a way of remembering this. So it's neighbor reports, right? Silent K, neighbor reports. So that is, right, I've got an AP, I'm going to connect to it. As I connect to that AP, the AP goes, great, you're having a great time. We've got really good SNR. We've got great data rate between the two of us. This is amazing. Thank you very much. I know you're going to leave me, and I want you to go somewhere good. So they give you a list of close APs that you could roam to. So rather than scanning every single channel that you have to, it kind of gives you a prioritized list of these are the channels that you're probably going to want to scan first because they're the ones I can hear loudest. All right, so that's the neighbor report. You've got 802.11v, which helps your clients evaluate their options. And the way that it does that, right, so we're in this room, I can see an AP there, there's one around there, there's one over there, there's one back there. So there's a bunch of APs, right? As you can see here, all of these APs, so I need, on macOS, I need something above neg 75, which as you can see is about 873 APs at the moment. Yeah, so I've got lots of options to pick from. You see here, this is quite useful. This one here has just gone red. Yeah? And that's the one that most of us are connected to, actually, by the looks of things. So what's great is if I'm coming into this space now, walking in, what happens is I look at what's called the QBSS load. This is what we're visualizing for you here. And it says, how busy are the APs? The Apple devices are incredible because what they'll say is, I'm not just going to connect to the loudest thing I hear, right? It will have this list of things that it can connect to, and it will check the first one. Okay, you're 10% loaded. Check the next one that's a bit further away. Okay, you're 20% loaded. Okay, check the one that's further away again. Okay, you're only 2% loaded. It will go to the 2% loaded one rather than the other two. Yeah, so it's awesome. And that happens through that 802.11v. So it helps it to evaluate its options. And then 802.11r, which is for faster roaming. So if you do have a .1x network where you're using certificate-based stuff, that obviously is quite a slow process, right, if you know how that whole kind of authentication happens. So what R does is the APs will go, I've already authenticated this person, and it will broadcast out to the other APs and say, hey, this guy's all right. So you don't have to go through that whole process again. So rather than your roam taking like 2 seconds, it will take a couple of milliseconds. So turn those on. APs. Like I said, lots of APs, way, way, way too high. You want to aim to have like 2, 3, maybe 4 APs above that trigger threshold in any one location. There are too many APs turned up too high in this space. Yeah, and what happens is your clients, because they do that evaluation, if they have too many too loud, it confuses them because they want to evaluate and make sure they pick the right one. So you want to try and reduce your APs down, make those cell sizes smaller so you have fewer clients per AP. Another way of thinking about it, right, is clients are connecting to the AP to connect to the network, right? So every client that's on one AP is sharing that cable connection. So if you think about it like you're unplugging that cable and you're plugging it into each individual client, right? You want to have as few clients per AP as possible. Now, again, with Wi-Fi, we tended to have this idea of, we'll stick them on the ceiling, turn them up to 11, really good signal everywhere. That's really counter to what we want to do, right? We want to have as few APs per client, per AP, few clients per AP as possible, so that they get a better experience. So we're using all of the spectrum that we have available to us. So if you look at this thing here, we've got this whole massive chunk of spectrum on the right there that's just not being used at all by these APs. And yet you've got loads of APs that are sharing the same channel over and over and over again. This is a really good example of a terrible Wi-Fi network. Right? So we want to balance those things out. So previously, I was always asked, like, how many APs do we need to cover this space? Right? That is not the question you want to ask. The question you want to ask is, how many APs can I put in here before it becomes a problem? You want to maximize the number of APs you have in space. And I don't sell APs anymore. I'm just telling you, this is the best way to do it, right? You want as many APs in a space as possible. So if you can turn them right down, if you can take an AP off the ceiling and put it under a desk, if you can do things like that stop that spread. Because now if you take an AP from off the ceiling and you put it near a desk, now it's closer to the client, so you can turn it down. It's easier to swap and change and look after if you need to. And you've got all these bags of water sat around them, making the cell size smaller again. That's us, by the way. And that's what we do in Stadium, right? That's what we do in Stadium design. Put the APs under the seats. If you walk into a stadium that's got under-seat design, it will not work unless the stadium's full. It's designed for the stadium to be full. Cool. Plug it in. If it doesn't move, just plug it in. Like, it will have a better time. All the wireless clients will have a better time. Like, the amount of times I go into a place and they're like, yeah, the Apple TV like disconnects and things like that. I'm like, oh, okay, like, show it to me. And it's just like hanging behind a TV and it's just powered. There's no, I'm like, why isn't it cabled in? It's like, it's got Wi-Fi. Right, and it's walking around, is it? Like, no, it's staying there. Just plug it in a cable. And then they plug it in. Oh, it works much better. Come on. Or printers. Printers is another one. Oh, yeah, we've got this wireless printer. We've connected to the network. Why? Who's walking around with a printer? Just plug it in. Like, Come on. It's much easier to diagnose, right? Like, is there a green light? Yeah, okay, it's working. Like, the Wi-Fi does not work like that, all right? Plug it in. 6 gigahertz is glorious. There are no legacy clients. There's no, like, rubbish happening in there. It's this, like, utopia of Wi-Fi heaven, 6 gigahertz. There's no backwards. The great thing and the worst thing about Wi-Fi is that it's backwards compatible, right? I can bring out a client from 92 and it will work on a Wi-Fi 7 network. And that's amazing, but it's also terrible. And so one of the best things that we now have is this 6 gigahertz thing where we can chuck all of our devices into there. And the beauty of that is, right, if you're a place where you've got a regular refresh cycle, you might have, say, half of your clients now are 6 gigahertz capable. The best thing you can do for your network is take down all your old APs, put new 6 gigahertz capable APs in, because you take half of your stuff out of 5 gigahertz, put it into 6 gigahertz, now everyone has a better time. Because the ones that are only 5 gigahertz capable now have twice as much capacity. Yeah, so it's genuinely one of the best things we do. And things like OFDMA, all these amazing features that we get told of about Wi-Fi, they actually work in 6 gigahertz because we don't have all these legacy clients like making us be backwards compatible. Yeah. Cool. So, kind of last point. Which vendor should you pick, Dan? Now that you're kind of vendor neutral, you kind of work with everyone, you're not selling one particular thing. Which vendor should you pick for Apple? It doesn't matter. They all use the same chipset. They're all coming from Broadcom or Qualcomm, right? They're literally, the only difference that it makes is the software they put on top of it, so how you manage it, their support that they offer you, the price that they give it to you at. Those are the things. In terms of like the actual Wi-Fi that comes out of them, no difference at all. I could take a Ubiquiti network and make it work as well as a Cisco network. They're literally the same thing. Now, the only kind of caveat to that is the actual hardware that they use might, Ubiquiti make a £100 AP, Ubiquiti make a £1,000 AP. They do not have the same things inside them, right? But a £1,000 Ubiquiti AP will do what a £1,000 Cisco AP will do. Yeah, and so that's the only thing that you need to kind of be aware of. Cool. Okay, so how do you design? This is where I make my money now. So this is our software here, right? So you build out a space, and you can see, like I've got an AP on the ceiling here. I can see the kind of coverage that I'm getting from that thing. I've also got an AP under a desk here, right? And you can now see the coverage that I'm getting from that thing. So when we're thinking about how we design, one of the things that I kind of really pushed for was this client view. And so you can choose to have, and we've got iPhones, MacBooks, iPads. And what's amazing about Apple is they tell us how their roaming algorithm works, right? And then we chat to them a bit and they give us a bit more information. But I can pick an iPhone and I can make it an iPhone 16 and I can stand here and I can tell you what the experience of that phone is going to be like before we've even built the building, right? And I can walk around that building and I can show you when it's going to roam. Because I've built a 3D model of the space. I know how the RF is going to propagate. I know the roaming algorithms that device uses. So I can walk around and I can show the CEO, yeah, this is why we've put in 5 times as many APs as we had before, because actually we've designed it now and it's going to work and you can see how well it's going to work and all that kind of stuff, right? So we do that. And I'll show you just real quick. So one of the things that I love about kind of Apple's software, right? Final Cut Pro is one of my favorite bits of software because my 13-year-old can use it, and a guy I know that's like a film editor can use it, and that's okay, right? Like my 13-year-old who just cuts a few things and puts it together and it does amazing. And then there's someone who's making like Hollywood films in it, can still use that same bit of software. And that's what we're trying to create here, right? So if I just do a quick demo, I'm going to add a map, which is basically a really crap photo I took of the fire plan in my room, just to show you it doesn't have to be a quality floor plan. And then we do a bunch of, stuff in the background, right? So we do things like we scale it for you, we scope it for you, so you can come in and literally just say, okay, how many APs am I going to need in this space? I'm going to use a Ubiquity AP. I'm going to use the E7, their nice new one. Yeah, you do the design for me, right? And we're going to go through and we're just going to do a design for you. And not only do we do the design, we'll tell you what channels you should use, what channel width you should use, how you should use them. And then you can come in and you can go, okay, well, how are my clients going to work in this space? And we've built all the walls for you and everything. And then you can literally just come in here and go, okay, cool. Like, this is how it's going to work. If I walk down here, I'm going to roam. I can see how everything's going to work. And that's taken me like no time at all, right? So that's how you design. And then one of the really cool things that we have this like survey software, survey hardware here. So this is taking in all the measurements all the time. We can plot that on a map. So if I show you, this is our office in Helsinki. And if I show you here, this is that behind the, yeah, thanks, Notch. Brilliant. Yeah, cool. So you can see here, right, this is our office in Helsinki. So we've walked around and we've done a survey of the space, and we can see exactly what's going on, right? So if I show you this one, so we've walked around and we can see, okay, this AP propagates in this way in this building. So one of the awesome things that we can do is we can use that real world measurement. So if you've got like a brownfield site that you're trying to do, we can come in and say, don't use the walls and objects that I've put in, actually use the environment learning that we've done from the survey. So I can come in here and I'm just going to select everything. I can delete everything, right? And now I can start going, okay, we want to upgrade to the new Wi-Fi 7 APs. I can place an AP, and you can see how it's being impacted. I've got no walls. We are using the attenuation model that we've got from the survey we've done, and you can see exactly how that particular AP is going to propagate in that building. So now I can do a design based on actual real-world data of how it's going to work. And then again, I can see how my clients are going to walk around and do that thing. So that's me. I've got a minute and a half left for questions, so I wanted to give some time for questions. I'm really sorry that I've spent so little time talking. Yes?
How do you deal with kind of like older kind of networking guys that are kind of set in their ways? How would you kind of present what you've just taught us today?
How would I present to those kind of guys? I would show them. I would visually show. Oh, yeah. So the question was, how would you take this to like an older infrastructure guy that has done networking for years and years and years? How would you kind of get them to understand this? But genuinely, I would show them with a visual tool because it's the only way that they kind of understand, are able to kind of get those concepts personally. That's how I've done it before.
So, Matt, awesome presentation.
Do you want socks or a hat?
I'll go for a hat.
Just to be clear, the last part you talked about removing the walls and objects.
Yep.
You are using the scanner because the walls could be different material,
yep.
and we don't know the real penetration. Yeah. So the scanner will tell you the
it gives you the
survey,
real world.
and then it knows where. Well, it doesn't know, but then it doesn't matter whether they're wooden walls or concrete or good.
Yep.
Thank you, man.
Yeah,
Excellent.
Yeah. Socks or a hat?
Socks.
What's the approach?
Yeah, so multi-level buildings, would you use like floor-based things? Yeah, so one of the kind of options that you have nowadays to make those cell sizes smaller that I was talking about is using APs with directional antennas rather than like an omnidirectional antenna, right? So you can fire the signal directly down. The problem with those that I was doing an office in London, and we fired this, tested it to see. It was so loud, like 3 floors down, that you were getting connected to an AP 3 floors above you, and it was terrible. So that was why we started putting APs under the desk to do that instead. So yeah, there are ways you can do that, and the measurement device will show you that, right? So as you measure the building, and when you're designing, you design in a 3D building, so you can layer the floors on top of each other. You can see the interference between the floors. All of that's taken into consideration, yeah, when you do the design. Hat or socks? Go on, Rolf. Yeah. Yeah. So again, you can design those in Hermina. So we can build out like attenuation zones, and then we can actually, the question was, how do you design for warehouses and tool racks and things like this? And so we can actually like float the client up and down. So if you've got like something that needs to pick at like 7 meters, we can actually show you what the signal will look like at that kind of 7 meters as well.
Like a forklift going up and how the signal would adjust as it goes.
Exactly that. Yeah, we can visualize that. Hat or socks? I've got one more pair of socks. If someone's got a question, yes. We'll wait for the mic. I'm so over time that I feel so bad. Oh, while we're doing that, you can actually, rather than use the survey hardware that I've got here, you can actually use a Mac to do a survey. So what I wanted to say, if you want to survey your environment to show your infrastructure team, hey, you've got a crap network, you can email me. I will give you a free license for Hermina so you can go and do a survey. Share that project with me. I'll talk you through what the problems are, and then you can put something together to show your infrastructure team. So send me an email, dan@hermina.com, and I'll get you sorted. Yes?
I didn't actually have a question. I just want to make Jack walk all the way over the mic.
Yes.
So.
Beauty.
No,
you get socks for that.
How much of your kind of work influence do you put in your home network? Because I like to fiddle around quite a lot, got Ubiquity set up at home. But I don't know if you're just one of those people who's just use the Virgin Media router at home and then put all the push into this.
Yeah, so I have a production network that my wife and kids are on because, yeah. And then I have about 4 demo networks of various vendors that I play with. Yeah, that's fun. I'll give you the socks. Thank you so much. I've taken up more time than I should have done.